Good afternoon. We will be discussing about coastal hazards today. And coastal hazards, when it comes to our mind, we think of these four processes. That is coastal erosion and accretion, and coastal inundation, which is caused by mainly cyclone, tsunami, and flooding. So then we have salt water intrusion in coastal aquifers and oil slicks. So these four parameters mainly we are considering as coastal hazards. We will discuss one by one. And first comes the coastal erosion. By definition, we learned that the landward displacement of the shoreline caused by the forces of waves and currents is termed as coastal erosion. And overall, the study of erosion and sediment redistribution is in total called coastal morphodynamics. So the coastal erosion and accretion is sometimes a continuous process. Normally somewhere it is eroding and somewhere it will be getting deposited, and the vice versa. And this process is continuous in the coastal region. This picture shows you the coastal erosion, and which is caused by the waves and currents along the coast, and continuously they erode the beach material inside the ocean, and it eroded material, it is getting deposited somewhere else. And now where it is erosion is taking place, and you know how much hazardous it is, and the nearby houses will collapse one day. And sometimes you might have seen the villages migrated landwards, the coastal villages in some part of in the east coast of India, and particularly in the Kakinada coast, etc. And this erosion and accretion process can be easily monitored by the satellites. And this picture shows you the map of erosion and accretion of Sagardeep Islands in the Ganga river mouth. And this green portion shows you the accretion where the sediments get deposited, and the pink shows the process of erosion, where sediments are getting, means the land mass is getting eroded. So this is the comparison between 1968 to 1968 to 1996 and 1996 to 1998. So you can take the survey maps if satellite data is not available, and you can compare with proper geometric correction, registration, etc. Then you can find out the amount that is eroded and amount that is where accretion has taken place. So satellite data helps you to study the erosion and accretion process. Apart from that, you can utilize the satellite data for classifying the image, means where you can find out the mangroves, where you can find out the water body and other land vegetations and mud flats, etc. So once you have mapped it using the supervised classification or unsupervised classification, you can find out the areas that is available in the coastal region, and later on some other date satellite data you can take, and you can go for mapping again, and the difference will give you the amount that is getting eroded in a particular thematic class. So the satellite data is nowadays is widely used to map this erosion and accretion process. And this is the land cover map of Gulf of Cambay, and you have here salt pan, turbid water, clear water, mud flats, and mangrove, marsh vegetation, and salt affected land, etc. So with the supervised classification is by going to the field, you can relate the satellite measured digital count of the image to that class, and several techniques are available to minimize the error, and you can map the thematic classes very accurately. And presently high resolution satellite data are available, so you can make utilization it make it means using this high resolution data, you can map the finer structures of the coastal ecosystem, and then you can further analyze it, whether erosion is taking place or not. And you can also generate coastal vulnerability index, taking the coastal slope, erosion and accretion, and geomorphology of the coast, and socio-economic variables, and that is distance from the shoreline. So taking different scores and giving weightage, you can also generate the vulnerability index map all around the coastal region. So now this is all about the studying of coastal erosion and accretion. Now we will discuss about coastal inundation. So as we have already discussed, the coastal inundation that is happens due to mainly two processes, that is cyclone and tsunami. So both of them, cyclone brings due to storm surge, the storm water enters into the coast, and due to tsunami also high huge waves, they bring lot of water mass into the coastal region. Apart from that, cyclone means during cyclone we have heavy rainfall in the coastal region, causing flooding all around the coast. So both cyclone and tsunami we will discuss in detail. So these are the breeding ground of cyclones, where these orange patches you are seeing, these are all breeding grounds for cyclone, where the sea surface temperature is greater than 26.5 degree Celsius, and the mixed layer depth is greater than 60 meters. So this condition mainly gives you means this situation is conducive for formation of cyclone. Apart from that, the you will never find a cyclone near the equator. Above the equator you will find the cyclone because of Coriolis force. The Coriolis force vanishes near the equator, so both north and south hemisphere away from the equator you will get the cyclone formed. So once the cyclone is formed in the coast, it normally goes inside the land and gets dissipated. So mainly it is getting generated near the coast, means in the ocean, and gets a lot of energy, and this energy is supplied by the heat of the ocean, and after gaining its momentum, the cyclone goes towards the coast, and then heavy wind, and due to heavy rainfall and storm surge. Three parameters are associated with the cyclone, which brings disaster to the coastal region. So this is the cyclone, and this is the track of the cyclone, and the white spot here indicates the eye of the cyclone, and the wind vectors are shown here, and the wind speed is very high near the core of the cyclone, and all around the sea wall, and heavy rainfall is associated with the eye wall. And so as you are going away from the eye, the wind speed as well as the intensity of the rain diminishes, and a cyclone is going along this direction, and what will happen, right side of the cyclone, you will get the wind direction. So along with the wind and this progress of the cyclone, this is aided up. So right hand side it is having a positive effect, and left hand side you see the it is opposing the moment of the cyclone. So devastation in the right hand side is more compared to the left hand side of the cyclone. So and the eye of the cyclone is sometimes very deceiving, and as it crosses the coast, when people come across the wind, means across the eye, they see the clear sky condition, so they think that cyclone has gone, and they come out of their house to do their daily work, and soon after that, after half an hour or so, depending on the speed of the cyclone, and the cyclone again appears. So this eye of the cyclone deceives the people that the cyclone is not there in the periphery around the eye. So you have to take care of that. And now what is happening during a cyclone is storm surge. So normally during the means in the eye of the cyclone, the pressure is tremendously less, so it will suck the water above. So the water level will increase due to low pressure of the cyclone, and this is depicted here. And as cyclone is moving, this elevated water mass also moving along with the cyclone. Now, apart from that, the barotropic effect, you have wind setup. When wind is blowing towards the coast, there will be a elevation of zeta due to the wind blowing towards the coast. This is called wind setup. So this is also aided, and this is one of the cause of storm surge. So this is small equation tells you about how the zeta is calculated, and this is the rho is the W is the wind speed, and Ct is drag coefficient, rho is the air density, water density, and acceleration due to gravity. Dx is the length of the coast, and so if wind speed is more, then you have a wind setup also will be more near the coast. So this these two effects, they create the storm surge. So this picture shows you how the coastal configuration is makes the storm surge worst. See, if you have a gentle sloping beach, then the storm surge water will easily enter into the coastal area. If you have a sharp slope and then the surging water will be within that, means it will act as a barrier and it will not cross the barrier. So this type of coast is safe enough when cyclone is approaching the coast. But gentle sloping beach, it is very dangerous. And once storm surge surging wave is approaching, and you have to vacate this place and go to a shelter. So we will be discussing about that in later. So this is the this picture shows you the storm surge decay coefficient. So when the surging water, suppose say 6.5 meters water is entering into the coastal region, so up to 1 kilometer it will maintain that condition of 6.5 meter, and after that it will start decaying. So to calculate the storm surge decay coefficient, we have to take these parameters into account. One is surge height, that is 6.5 meter or 2.5 meter, depending on the intensity of the cyclone. If it is a super cyclone, then the surge height will be 6.5 or more than 6.5. If it is medium, so depending on a scale, you can estimate what will be the storm surge height. That is described in Saffir-Simpson hurricane intensity scale. We'll see later. And this is the surge height, and this is the average elevation of land at the end of the surge. So this is the from land elevation model or elevation data, you will get this elevation in meters, and the total inundation width that you will get. This is the total inundation width, and you have width of constant surge. This is the small width of constant surge is 1 kilometer or so. So taking this into account, you can calculate the storm surge decay coefficient. Later this decay coefficient, it can be used to calculate the means flood depth of the map. So flood depth means this water, how much, where it will be. So when you will put it means the population data over that, then you can calculate the vulnerability due to the storm surge. Now this is this tells you Saffir-Simpson hurricane intensity scale, and the scale is divided into 5 categories. One where the central pressure means eye of the cyclone, where the pressure is greater than equal to 980, then slowly it is decreasing. So as it is going on decreasing, cyclone is becoming more intense. So similarly, the wind speed also around 120 kilometers per hour. Then it increases to more than 150, and then 180 and 200, and then greater than 250. So at that point of time, central pressure will be less than to 920 millibars. So this storm surge surging water will be 1 to 2 meter for a scale of 1, and the damage will be minimum. So then if it increases further, damage is moderate, and damage will be extensive when it is 3 to 4 meters. and extreme damage you can witness if storm surge is 4 to 6 meters high, and greater than 6 meter it is catastrophic. Mainly the Saffir-Simpson scale reaches scale number 5 represents the super cyclonic situation. When it is a super cyclone, then wind speed will be less than 920 millibars, and wind speed will be greater than 250 kilometer per hour, and storm surge will be greater than 6 meters, and it will be the devastation will be catastrophic. So this image tells you this is the east coast of India in Odisha, and this is the Bangladesh region, and you have Sagar Islands here, and the red patches shows you the low-lying area where the height is 0 to 1 meter depth. So whenever a cyclone is approaching or a tsunami wave is approaching, so this area will be easily getting inundated, and so always this particular region they experience the cyclone every year. So every year there is a economic loss due to the cyclone, and devastation. People have witnessed devastation all along the coast. Every year this cyclone is getting formed in Bay of Bengal and crosses any of the coast, and so these are all causes, that is local primary physical responses, and this is primary damage effects, and indirect secondary effects that happens due to the cyclone. And few of the same thing will happen. This primary effects and secondary effects also will happen due to the impact of tsunami. So let us first consider the tropical cyclone. What it matters is local tide. So local tide time is very important when a cyclone crosses. So if it is a spring tide time and the storm surge is coinciding with the spring time, normally during spring tide the water elevation will be more in the ocean. So in addition to the storm surge, this additional mass of water due to tide will cause the devastation more, and the coastal configuration, what you have already seen, if it is a sloping, gentle sloping beach, then the storm surge water will easily enter into the coastal villages, and it will wash away the house and property, livestock, etc. And the coastal, that's why the coastal configuration and local tide time is most important parameter for the storm surge, effect of storm surge. And this is the tropical cyclone, how it is formed when low pressure is associated with the tropical cyclone, then wind is associated with the tropical cyclone, and torrential rain. So these three parameters are associated with the tropical cyclone, and each one is means low pressure and high wind. They contribute to formation of storm surge, and the more the storm surge and loss of life will be more. So and then torrential rain that will create flooding. So flood also will take away your life. So loss of life is the main thing what you experience during a cyclone and tsunami also. And tsunami, only the rain and is absent and wind is absent. Otherwise, in the coastal plain, flooding will be there up to some extent, not like cyclone. Cyclone, the maximum rainfall will be there when it is means crossing the coast, and all around the means you have depending on the extension of the cyclone, and everywhere rainfall will be there, and the river channels will be flooded. So that intensity will be there. But in case of tsunami, only the surging waves will come, and it will recede, it will take away the debris along with it. So it will create a coastal disaster and coastal flooding. And these are the primary damage effects. One is flooding avulsions. The river course will be changed, and somewhere it is beached, somewhere means the river course will be means modified due to the impact of flooding, etc. And coastal erosion and damage to the property, and damage to the ports and harbors, and fire, and disruption of transport and power. So these are all associated with the flooding, and also these are indirect secondary effects. One is saltwater intrusion. So ocean water will enter into the fields, and the it will bring damage to the crops, and water supply also will get contaminated due to flood water entering into the system, and land subsidence. All these things will lead to mainly starvation, and finally disease. So this is a means process normally the people in the coastal area prone to these disasters are facing every year. Then let us talk of tsunami. And tsunami, as you know, is called a seismic wave, are most frequently caused by earthquakes beneath the sea. So if there is a earthquake beneath the sea, a large amount of means it will give a jerk to the water surface, and at a particular point water surface will get elevated, and it will create a seismic wave, and that wave will further pass through means entire, it will act like a shallow water wave, and the when it will enter into the coastal area, its wave height will be enormous. So in general, anything that displaces a large volume of water can cause a tsunami. That is a volcanic eruption under the ocean, or a submarine landslide. Rarely if a meteor's impact is coming from outer space and dashing on the waters, seawater. So a large chunk of water will get displaced, and that displaced water will create a wave which will come to the coast as a tsunami. So these are the main mechanism tsunami approaches the coast, and we will discuss about the characteristics of the tsunami. A tsunami can travel great distance very quickly without losing much of its force. So means thousands of kilometers it can travel without notice. Means if you are on a ship, you will not feel that tsunami wave has passed underneath you, and it will travel, and only its impact will be visible in the coast away from the origin. In this way, tsunami can cause great damage a long way from its point of origin. So, the point of origin will be somewhere and the damage will be somewhere. As well, a tsunami height in open water may only be a few feet, but its height can increase greatly in shallow water near the land. As the tsunami wave acts like a shallow water wave, means entire ocean basin wavelength is very long, and the entire ocean basin acts as a shallow water. So, when it is approaching near the coast, it feels the bottom, so it's means the height will be means accumulated, and the water level will be accumulated, and a huge wave will get formed near the coast. So, there are two things that will happen as soon as tsunami is approaching. There will be a wave set down, and when the means coastal water it will recede towards the ocean, so exposing the material of the coast, and people will get attracted to collect the sea material, and they after few minutes the huge wave will come as a tsunami, and it will engulf them. So this is wave set down and wave set up. So wave set down, it exposes the beach, and wave set up, huge wave will get formed and come as a tsunami. So a tsunami height in open water may be a few feet, but as it approaches the shallow coastal water, its height will be huge. In the deep ocean, a tsunami may travel at a speed of 500 miles per hour. So, this is the impact of you can call tsunami, or you can call storm surge. The means the boats and the fishing trawlers, etc., will be thrown away on the land. Push means from the jetties. They will means so much of force, it will lift the heavy boats, etc., and throw it on the beach side. So, and destroying means the whole infrastructure all around the coast. And normally this is the cyclonic picture, and the vehicles, etc., will get stranded for days together, and if you are caught in between the flooding water due to torrential rain of the cyclone. And due to cyclone or tsunami, because force will be that vigorous, and the underneath means sediments, etc., will be carried away by the water, and the railway line, what you are seeing, is exposed. And so here you can means whether it is cyclone or tsunami, if you are living in the coastal area, you have to think of making the shelters. Either you call it cyclone shelter or call it tsunami shelter, or whatever it is. So you have to take a survey map, or you can take the satellite data. So their survey maps, it will give you the detail data of the means past data, and satellite data will give you the present situation data and new streams, etc., and digital elevation model will give you the height information around the coastal region. And the field statistics, you can relate it taking the data from the past cyclonic event, means storm, where a worst storm surge has taken place or a tsunami event had taken place. So all this data you can put it in geographic information system, and then you can identify a suitable site for construction of cyclone shelters. These cyclone shelters, excuse me, these cyclone shelters will be useful during the storm surge or during a tsunami warning. So what you can do, you can take the river coast, and your cyclone shelter should be away from the coast as well as away from the river channels, because if it is a flooding situation will occur, then river water also will make your movement crippled. So the cyclone shelter should be created in such a location that easy communication should be there, and it is away from the water. And similarly, this map is created around the taking DEM information and the storm surge decay coefficient information, and a flood depth map is generated using the those two parameters. So this red patches, they show the flood water is high here, and so the population living here will be vulnerable, and the vulnerability goes down where it is you are going away from the coast. So there, wherever the water elevation is a little bit high, means the land elevation is a little bit more, there you are safe. So you, by leaving this region, you can think of means keeping all other criteria, you can have a means a cyclone shelter map. Then now we will discuss about oil slicks. So this oil slicks nowadays we are means this news is coming in the newspaper, and that is, you can see the disaster due to the oil spills, and you can see how the seabirds are affected and they are unable to fly, and finally due to starvation they die on the shore. And this is the turtle, and a dead turtle, their wings etc. are contaminated with the oil slicks, and their movement is restricted. So due to starvation they die. And similarly, this is the a brown pelican whose wings are covered with the oil. They are unable to fly and waiting for rescue. And this is the dead seabird covered in sticky oil, and this is the what you call flora and fauna of the coastal region are getting affected by the oil. And this is a oil spill contaminated beach in northern Spain, and so when this oil spill comes to the coastal region, and tar balls are getting formed and they are getting deposited near the coast and making the coast coast useless, because it will hamper your tourism, and it will destroy the flora and fauna of the ecosystem, and it will bring a disaster. So let us now study the physical properties of the oil. What happens? The rate at which an oil spill spreads will determine its effect on the environment. So the most oil tend to spread horizontally into a smooth and slippery surface, which we call slick, and it floats on the top of the water. And there are let us discuss about the factors which affect the oil spill most. That is, there are three factors which affect the oil spill most. That is, one is surface tension, then second is specific gravity, and third one is viscosity. Specific gravity is the density of a substance compared to the density of the water. So most oils are very lighter than water. That's why they float on the top of it. And when the specific gravity of a oil spill increase, the lighter substances within the oil evaporate. So what happens? It's when lighter substance evaporate, then their specific gravity will increase. So heavier oils like vegetable oils, animal fats, they sink and form the tar balls, and later they interact with rocks or sediments on the bottom of the water body, and these tar balls finally get attached to the sand, and finally it destroys the ecosystem. And next one is surface tension, and it is the measure of attraction between two surfaces, that is molecules of the liquid, and the higher the oil surface tension, it will try to stay in a this field, means remain in the same place. Spill will remain in the same place. So if the tension is high, if the surface tension is very low, then the oil will spread even without the help of wind or current. So normally when spill, it is left to the force of the wind and current, and they will carry it further towards the coast or away from the coast depending on the wind speed and current direction, etc. And because if it is in a increased temperature condition, it will reduce the liquid surface tension. So oil is more likely to spread in warmer water compared to the colder water. So these are conditions you have to see when the oil spill has taken place in a particular region. Then third one is the viscosity, is the measure of liquid's resistance to the flow, and the higher the viscosity of the oil, the greater tendency of it to stay in one place. And this slide shows you what happens. Normally the lighter portion, it's getting evaporated, and the oil remaining tar balls or so, they run off and comes to the ocean, and in the oceanic, if there are any accident and spreading is taking place, and while spreading, evaporation is taking place, then it is water in oil emulsification takes place, then then oil in water emulsification takes place when it goes inside the water body, and dispersion takes place, then biodegradation takes place, and finally tar balls will get deposited in the bottom. So this process, what it happens, and it affects the flora and fauna of the coastal ecosystem. So this is the picture of August 2010, where a foreign cargo ship which collided with another vessel about 10 kilometers of Mumbai harbor, and you can see the oil spill is coming from the ship, and this oil contaminates the ocean. and sometimes the ships normally means got damaged due to stuck up in the near coast area. It is if it is away from the shipping channel, then finally it is very difficult to take it back, and it is stuck up in the near coast, and there is a dangerous situation. The oil may spill here. And sometimes the pipelines which carry oil, they break inside the ocean floor, and the oil plume starts from here, and the surface expression will take place after some time, and depending on the current speed at this surface, it will be carried out to the further. And this graph shows the extension of spread, where the as time axis in this x-axis, and extension of spread in centimeters in y-axis. As you see, between 0 to 20 seconds, the spread is very less, and after a span of 140 seconds, the spread has gone maximum. So this is the controlled lab measurement, how the oil spread is taking place. And this is the oil appearance once you are putting some oil in the water, and how it looks like, and the appearance and its thickness is given here. If it is silvery sheen, then thickness is 0.05, and rain brown sheen 0.15, reddish brown sheen 0.5, brownish 2 micrometer, and dark is 10 micrometer, dark brown is 50 micrometer. So from the appearance, you can relate the appearance to the what you call thickness. So the now this picture shows you the oil slick which is monitored by the MODIS, and near the coastal area normally it is turbid waters, and in the turbid water the oil patch is there. Easily it can be distinguished at the if you are using the color sensors, that is visible sensor, easily you can find out the patch of the oil in the water. And this is the multispectral image data from portable sensor which shows you the thickness of the oil in different colors. Okay, so this is the original image, and this is the classified image, and thin oil is in this color, and yellow shows you thickness of oil 0.05, and the green patch shows you the thickness is around 0.07 millimeter, and you have red patches, thickness is 0.09 millimeter. So you can relate this thickness and use the multispectral data, means visible remote sensing data, to find out the thickness of the oil. Now, apart from that, you can also use the SAR data to detect the oil spill. So the normally wherever the spill is slick is there, oil slick is there, so there will be a smoothness in the water surface, and the capillary waves will be suppressed, and as a result, the you will not get the backscattering from the surfaces. So the imagery will the SAR image, you will get a dark patch wherever slicks are there, oil slicks are there. All around you will have some backscattering. Only wherever oil slick is there, you will not get any backscattering. So final product will be dark patch here where slick is there. So interpreting this way, you can find out the oil slick using the synthetic aperture data. And sometimes there are look-alike conditions. Here the oil spill is there, but this dark patch is not due to oil, and this is due to low wind condition, and here it is due to current. So this is not oil patch, these are look alike situation. So you have should have an expert system to find out the look alike and the oil patches, and you should use a different what you call means compound remote sensing, means you can use visual remote sensing, you can use thermal remote sensing and SAR data, all these things you can, and field information to determine whether oil is there or not. And here this is the oil spill in east coast of India, Tamil Nadu during 2010 January, and you can see how oil has destroyed the beaches around. So oil in January 25th, two cargo ships collided off the Ennore coast in Chennai, causing oil to spill into the sea, and the spill has been the spill has been polluting Chennai beaches. So this is the oil spill means reached the coast, and the volunteers, they started pumping the oil out of the water, and a lot of activity had taken place during the time, and and these are the pictures of how they have pumped the oil from the coast. And satellite data also used to monitor the oil spill. Here it is Sentinel-1 picture, and before the accident took place, and this is the aftermath of it. And more clearly, this is the port area where the collision had taken place. This is the before, and this is the after. You can see the oil spill patches here. And somewhere some dark patches are look alike situation, so don't get confused. And these are the visible remote sensing data from different satellites, both Indian satellites and foreign satellites, showing the distribution of oil. And this data is also from visible remote sensing data. Yeah, this is the collision location and oil spill, how it has spread, and this is the visible data, and this is the Cartosat data. So what a sensor can provide, that is, the sensor can provide the following information for oil spill contingency planning. First is the location and spread of an oil spill over a large area. Second, the thickness distribution of an oil spill to estimate the quantity of spilled oil. Then third is a classification of oil type in order to estimate environmental damage and to take appropriate response activity. That's what you have seen, how they have pumped the oil. Once you know the location where the oil will come, using your different techniques, satellite data, monitoring, modeling, etc., you can find out, and timely you take a contingency planning, and timely and valuable information to assist in cleanup operations. Then we will discuss about saltwater intrusion. The saltwater intrusion or ingress in the land, in the mainly coastal aquifers. When we pump the coastal aquifers, the level saltwater means freshwater level will go down, and it will get replaced by the salt water from the mm, salt and fresh water interface. So there are natural processes which makes the salt water intrusion, and also man-made processes. So natural processes are in most of the coastal aquifers. Salt water has a higher density and has a higher water pressure, can push inland beneath the fresh water. And when we do the groundwater pumping, excess groundwater pumping drops the groundwater level, which reduces the water pressure and allows salt water to flow further inland. So other contributors to saltwater intrusion includes navigation channel or irrigation channel, etc. And they bring, means sea water is entering through the channels to the land, and when the sea level rise, the water level also will get affected. And extreme events like hurricane, storm surge, or tsunami, they bring salt water inside the land. So it will get affected. So these are Heisenberg relation, which tells you the fresh water means the small h represents the fresh water height above the sea level, and z represents the fresh water level below the sea level. So if the this equation is related to z is can be estimated from density of fresh water divided by difference of density of fresh water and seawater. So that will give a relationship that z is equal to 40 of small h. So this is the relationship. Once the ratio is disturbed, then fresh water means saline water will ingress into the system. And this is the in situ measured salt water content in the all around the Bhavnagar area, and the vulnerability index means area is marked. Red indicates highly vulnerable area, and blue less, and the orange represents moderate vulnerable area. And this is the salt affected villages of Gulf of Camber, and from the satellite data. Thank you.